Let your body sink into the quiet. Whatever the day held, you can set it down now. Come with me, gently, into the quiet story of a hoard of treasure sleeping beneath a riverbank. If nights like this help, subscribe. There's a fresh one every evening. The signal came in April, a gray Somerset morning, the air carrying the cold particular to freshly turned agricultural ground, and the search coil of Dave Crisp's metal detector passing slowly over a field edged by the floodplain of the River Frome. The coil moved at a steady pace, the way a practiced detectorist moves it, methodical, unhurried, tracking back and forth across the disturbed soil left by the plow. The field sat close to the river's margin, in that low, flat country where Somerset's drainage channels run between hedgerows, and the sky seems wider than it has any right to be. And then the control unit registered something. The signal tone shifted. The reading held steady on the display, strong and clear, beneath approximately 30 centimeters of dark earth. There is a particular quality to a strong, stable reading. It holds in a way that a scattered or uncertain signal does not. A fragment of modern debris will often give a reading that flickers or shifts as the coil angle changes. What Dave Crisp's detector found that morning did not flicker. The signal stayed firm across repeated passes, consistent with the kind of dense, coherent mass that a practiced detectorist learns over years to take seriously. The field had been plowed recently. The soil was open and loose across its disturbed upper layer, darkened by the particular wet of an early English spring. The morning was quiet around the reading on the display. What Crisp did next is the detail that would shape everything. He began to dig carefully, by hand, working down through the loose upper soil until he found the rim of a ceramic pot. Only the rim, a dark arc of fired clay at the base of a shallow hand-cut trench, sitting in the undisturbed horizon below the plow zone. He recognized what that meant. A contained deposit, intact below the machine-broken surface, the ceramic vessel still sealed against the surrounding soil matrix. He stopped digging. He put down his tools. He stepped back from the trench and made a telephone call. The Finds Liaison Officer system in England exists precisely for this reason. A network of trained professionals embedded within county councils and regional heritage bodies. Their role to act as the first point of contact between finders and the institutional machinery of heritage law and archaeological practice. The system was established under the Portable Antiquities Scheme, itself a consequence of the Treasure Act 1996, and by April 2010 it had been operating long enough that a responsible detectorist in Somerset would know the number to call. Crisp made that call from the field. The ceramic rim sat undisturbed in its shallow trench behind him while he waited. The decision to stop digging after exposing only that rim is the kind of decision that is easy to describe and genuinely difficult to make. Standing alone in a quiet field with a significant find at the base of a hole in the ground and no one watching, the value of what rested below that rim would not be known for weeks. The size of the deposit was not yet established. What Crisp knew at that moment was that the vessel appeared to be intact below the disturbed plow zone, and that whatever it contained was best left for trained excavators with the tools and the documentation methods to record exactly what was there and exactly where everything sat. He stepped back. He kept the site undisturbed. He waited for the professionals to arrive. The Portable Antiquities Scheme functions through a network of finds liaison officers placed county by county across England and Wales, each responsible for recording finds made by members of the public and for coordinating the response when those finds appear to meet the legal definition of treasure or are of particular archaeological significance. The Somerset Finds liaison officer received Crisp's call and initiated the process that would bring the archaeological team to the field within days. This is the institutional machinery behind the calm surface of a discovery. Calls made, records opened, schedules arranged, equipment packed for fieldwork. The field near the River Frome sat where it had always sat while those arrangements were made. Somerset County Council and the British Museum dispatched an excavation team. The partnership between local heritage bodies and the National Museum follows an established pattern in cases where finds have both regional significance and national legal implications. A find of probable Roman coins in a sealed ceramic context falls within the Treasure Act's definition, which means Crown interest is engaged from the moment the find is formally reported, and which means the institutional response carries both legal and scientific weight. The team that arrived at the field brought with them the tools for precise documentation rather than rapid extraction, photographic equipment, drawing boards, soil sampling kits, the apparatus of an excavation designed to record before it removes. Photographing a deposit in situ before removal is a practice whose importance is difficult to overstate and whose rationale is worth holding clearly in mind. Once an object is lifted from its burial context, the spatial relationships that surrounded it, its precise position, its orientation, the objects lying against it, the matrix immediately surrounding it, the layer it rested in, are gone. They exist only in the record made before removal. This is why the excavation team at the Frome Field did not simply extract the ceramic pot and its contents. They photographed the deposit from multiple angles. They drew the deposit by hand on paper, recording positions and dimensions with the precision that field archaeology requires. What they captured in those photographs and drawings was something that had been fixed in position since the late Roman period. The photographs and drawings showed a ceramic vessel that had partially collapsed under the weight of the overlying soil across 17 centuries. The pot had fractured, as buried ceramics tend to do under sustained pressure, and the coins it had contained had splayed outward from the center, spreading into the surrounding matrix in a rough radial pattern. This pattern was itself informative. The way coins distribute themselves within and around a collapsed vessel reflects the orientation of the vessel at burial, the packing density of the contents, and the mechanics of how the ceramic fabric gave way under pressure across time. Each coin's position in that pattern was recorded on the field drawing before anything was moved. The plan that resulted was a spatial document of a moment that had been frozen in April, sometime in the late 3rd century AD, and remained frozen until April 2010. The soil itself was as important to the excavation team as the objects within it. Soil samples were taken from inside the pot, from the compacted matrix that had filled the spaces between and among the coins over centuries of slow percolation. Samples were taken from the surrounding matrix, the silty clay immediately outside the vessel's collapsed walls, and samples were taken from the undisturbed subsoil below the burial horizon, the layer that had not been touched by the deposit and could therefore serve as a baseline for comparison. These 3 sample sets, internal, surrounding, and underlying, would allow laboratory analysts to characterize the microenvironment in which the coins had spent 17 centuries. The notably fine condition in which many of the coins were eventually found had to be understood in terms of that microenvironment, the chemical and physical conditions of the burial, not simply assumed to reflect the quality of the coins at the moment of deposition. The practice of taking soil samples at multiple defined contexts is a standard excavation protocol in British field archaeology, and it reflects a view of the buried deposit as an environmental archive as much as an object cache. The layers of soil around a buried object record the history of that burial, the chemistry of the water that percolated through over centuries, the biological activity at different depths, the pollen and phytoliths and molluscan remains that accumulated in each distinct horizon. Each sealed glass vial of dark Somerset floodplain soil, collected that April morning, carried within it a fragment of that archive. They would be labeled with context numbers corresponding to their precise positions within the site and transported alongside the ceramic vessel and its coins for analysis in the conservation laboratory. The morning around the trench was quiet. The field extended away from the excavation in every direction, flat and dark with turned soil, edged at its margin by the tree line above the River Frome's floodplain. The work was careful and slow in the way that genuine archaeological excavation is always careful and slow, not because the people doing it are moving reluctantly, but because the work itself demands a pace calibrated to the fragility of what is being uncovered and the irreversibility of each intervention. A brush passed over a coin surface removes particulate matter that cannot be returned. A trowel pressed at the wrong angle can shift an object from its recorded position before its position has been fully captured. The team worked at the pace the deposit required. The ceramic vessel, once exposed more fully, could be seen as a pot of modest dimensions, a utilitarian object of Roman provincial manufacture, the kind of vessel that would have been common and unremarkable in its time and place. Its surface was dark with the silty clay that had pressed against it for 17 centuries, a darkness that was the accumulated close contact of the burial environment rather than the original color of the fired clay. The pot had a rounded body and a rim opening consistent with a relatively wide-mouthed form, practical in its shape rather than decorative, the kind of object chosen for containing something rather than displaying it. The collapse pattern of its walls, visible in the excavation photographs, was consistent with gradual failure under soil pressure rather than sudden fracture, suggesting the ceramic had survived intact for a considerable period before eventually giving way. The extraction of the ceramic sherds and the compacted coin mass was conducted with the care that the deposit's condition demanded. The coins that had been contained within the pot had over 17 centuries of sealed burial pressed against one another under the weight of the collapsed ceramic walls and the overlying soil, compacting into a mass that could not simply be lifted out as individual objects. The compacted assemblage was removed as a unit, secured and supported for transport. The sherds collected from the surrounding scatter zone and bagged and labeled for later reconstruction. The soil samples, in their sealed glass vials, were packed for the laboratory. The field drawings and photographs constituted the site record that would allow the deposit's original spatial arrangement to be referenced even after every element of it had been physically removed and transported to London. And the British Museum's Conservation Laboratory in London received the compacted coin mass and the ceramic sherds within a secure transfer process calibrated to the legal status of the find under the Treasure Act. Once material has been formally reported as treasure, its handling falls within a defined institutional framework, chain of custody documentation, controlled storage, professional conservation management. The laboratory that received the Frome material is equipped for exactly this kind of work. The careful mechanical separation of compacted metallic assemblages using tools and techniques developed specifically to recover individual objects from consolidated masses without damaging their surfaces or distorting their recorded positions. The separation process took several weeks. This is not a surprising duration for a deposit of this size and condition. The conservators working on the foam material used fine pneumatic tools, instruments that deliver controlled bursts of compressed air to dislodge compacted matrix without the mechanical force of a metal implement, and wooden tools no wider than a pencil, pressing gently at the join between two coins that had lain face to face in sealed ceramic darkness for 17 centuries. And pneumatic tools in conservation work are chosen for their precision, the ability to direct a controlled intervention at a specific point without transmitting force to the surrounding material. Wooden implements are chosen because wood is softer than metal and cannot scratch or gouge a coin surface the way a metal probe might. The coins came free one by one, or in small groups of 2 and 3, where they had adhered most tightly during their long period of sealed burial. Each coin, as it was separated, was examined for its readable surface detail, the portrait, the legend, the reverse type, and assigned a position within the assemblage's emerging catalog. The conservation laboratory is a quiet working environment when this kind of meticulous, detail-focused work is underway. The light is controlled and consistent, calibrated for the examination of small metallic surfaces. The tools are laid out in order on the workbench. The work proceeds at the pace the material allows, which is never fast, which is always the product of a decision to let the deposit's condition set the terms of the recovery. What the conservators found, as the coins separated from the compacted mass and took their places in the accumulating catalog, was a deposit spanning 5 decades of Roman coinage and encompassing the reigns of multiple emperors, from the mid-3rd century through to the period of Carausius, and the commander who had declared himself emperor of a breakaway Britain and issued his own coins from mints in London and elsewhere in the province. The range of material within the pot spoke to decades of gradual collection, coins accumulated over years rather than gathered in a single transaction. But those interpretations would come later from the numismatists and historians who would work with the cataloged assemblage once conservation was complete. At the moment of separation, the conservators were focused on the coins as physical objects, on preserving surfaces, recording details, completing the inventory that the deposit's removal from the ground had made both possible and necessary. The field in Somerset was left as fields are always left after an excavation, the trench backfilled, the surface returned to its approximate prior condition, the disturbed soil replaced in the sequence it had occupied. There is no visible sign in that field near the River Frome's floodplain margin of what was found there in April 2010. The agricultural ground continues to serve its agricultural purpose. Daphrum runs alongside it, as it has always run, the river's course slowly tracing its way across the flat floodplain, as it has done since before the deposit was placed in the ground. The gray April sky that had covered the morning of the discovery was replaced by the gray April skies of subsequent springs, and then by the different weathers of subsequent years, none of which affected the absence of what had been removed, the stratigraphic integrity of the deposit, the fact that the coins were found in their original burial context, undisturbed and in sequence, rather than scattered across a disturbed layer or recovered individually from a site already damaged by extraction, is the consequence of a single decision made in a quiet field. Crisp's choice to stop at the rim and make the call determined everything that followed. The soil samples that would later yield radiocarbon dates and pollen evidence and chemical profiles of the burial environment existed because the deposit was left undisturbed long enough to be properly sampled. The spatial record of the coin's position in their radial scatter pattern existed because the excavation team was given the opportunity to photograph and draw before extraction. The reconstructed ceramic vessel existed because its sherds were collected from their original positions rather than discarded or lost in an unsupervised recovery. There is a version of this story in which none of that happened, in which a different finder, making a different decision, extracted the coins from the pot by hand in a matter of minutes, pocketed what was recoverable, and left the ceramic sherds and the surrounding soil context destroyed and unrecorded. That version of events happens in British fields with some regularity, and its consequence is a deposit reduced from an archaeological resource to a scattered set of objects whose original context can only be guessed at. What the Hoard story demonstrates in its particular quiet way is the difference that a single decision can make at the exact moment of contact between a finder and a find, when the deposit is still intact and the record it contains has not yet been lost. The institutional process that Crisp's phone call set in motion was not invented for the Hoard. It existed because other discoveries in other fields had demonstrated what was lost when it was not followed. The Portable Antiquities Scheme, the Finds Liaison Officer Network, the Treasure Act's legal framework, the British Museum's conservation capacity. These structures existed as accumulated responses to accumulated experience of both successful and failed recoveries. The Hoard moved through those structures cleanly, each stage following from the previous one, as the process was designed to allow, from the phone call in the field to the weeks of careful laboratory separation in London. The Somerset floodplain soil, dark and silty and cold with the dampness of an English spring, had kept what was placed in it across 17 Roman centuries and many English ones. It had kept the coins dry enough that their surfaces remained readable and their legends remained legible. It had kept the ceramic vessel stable enough that its sherds were recoverable and its original form could be reconstructed. It had kept the organic traces, the degraded remnants of what may have been a textile wrapping placed inside the pot with the coins, in conditions that allowed laboratory analysis to identify their likely character. The soil had done its part. The discovery process, when it finally came, would do its part across the weeks that the conservation team worked through the compacted assemblage at the British Museum. The field in Somerset continued to be plowed and planted and left to weather in the usual cycles of agricultural ground. The Frome ran alongside it, carrying the usual runoff from the Mendip Hills to the north and east. The gray light of an English spring moved through its usual calendar without ceremony. Whatever had been preserved for 17 centuries in the sealed interior of the ceramic vessel was now in London, being separated coin by coin under controlled lighting with tools no wider than a pencil, and the field was simply a field again, unremarkable from the road, the dark-turned earth offering nothing to suggest what had been found there in April. The trench Crisp had hand-cut was shallow, only deep enough to expose the rim of the pot at its base, the work of an hour at most before the phone call was made, and the tools were set down. The rim sat at the base of that shallow trench, a dark arc of fired clay in the compacted silty clay of the undisturbed burial horizon, its surface continuous with the surrounding soil in the way that objects buried for a very long time become continuous with their surroundings, absorbing the color and texture of the earth that is pressed against them across centuries of close, still contact. The coins below that rim were packed tightly inside the vessel, sealed against the surrounding environment by the ceramic walls, accumulated there by someone who had left them and not returned. The field was quiet around the trench. The morning was gray and still. The find sat in its hole, undisturbed, as it had sat since the late 3rd century, for a little while longer, holding its 17 centuries of silence, waiting for the excavation team to arrive. The long padded table in the British Museum's conservation suite held, when the work was finally complete, a sequence of coins arranged by rain in careful rows. The room was quiet in the way that rooms used for precise work tend to be quiet, not empty of sound, but attended by a particular kind of stillness, the stillness of close attention sustained over many weeks. 766 coins, each one separated from its neighbors by hands using instruments no wider than a pencil, each one photographed and assigned a number and a position in a running catalog before it was moved to its place in the sequence. The work of separation had taken the better part of a month. The work of arrangement, once the coins were freed from one another, took considerably less time. The conservators could see, spread before them on the padded surface, a numismatic record of 50 years of Roman coinage, the earliest pieces worn and dark with long handling, the latest ones lighter in color and noticeably thinner, their silver content fallen so far as to be barely present in the alloy at all. It begins with the pot itself, the ceramic vessel that arrived in the British Museum's conservation laboratory, transported from Somerset under secure conditions after its discovery in the turned soil of an agricultural field near the River Frome, was not intact when it reached the conservators. It had collapsed at some point across the 17 centuries it spent underground, the weight of the coins and the slow pressure of the surrounding silty clay sufficient, over that duration, to crack and compress the fired clay walls. What arrived was a compacted mass, coin stack fused loosely inside the surviving sherds, the whole package dense and dark, with the particular black-brown color of floodplain clay. The ceramic was not decorative. The pot was a working vessel, a container of the kind used throughout Roman Britain for storage, its walls plain and functional, its surface unglazed, fired to a dark finish. It had done what it was made to do. It had held what was placed inside it, and it had held it for a very long time. The reconstruction of the vessel from its recovered sherds, cleaned first of adhering clay matrix, then examined for join lines, then assembled using fine adhesive applied under magnification, revealed a container with an estimated original capacity of approximately 2 liters. That figure matters because of what it confirms about the deposit. The recorded weight of the coin assemblage, measured after conservation, was approximately 1,785 kilograms, and to get a pot of that capacity, with coins packed closely enough to fill it to near capacity, would have felt dense and heavy when lifted. It would not have been an object carried casually in one hand. It would have required a deliberate grip. Both hands, perhaps, the weight of it settled in the arms. The person who carried it to the place where it was buried would have felt that weight as a physical fact, the specific gravity of 17 centuries of future archaeology carried in a ceramic vessel across a floodplain field. The reconstructed pot sits now on a museum conservation table in photographs taken for the published catalog. Its sherds are rejoined with fine adhesive, the hairline traces of the fractures still visible across the vessel's dark-fired surface, each crack a record of the pressure that accumulated around it across 3 centuries of Roman rule, and then 14 more after Rome withdrew from Britain entirely. The shape is plain and solid. There is nothing about it that invites extended description. It is a pot, the kind of pot that held things, that served a purpose, that was chosen for this particular purpose because it was available, sealed, and strong enough. The contents are what the vessel exists to have preserved. The 766 coins are all of the same denomination. The Antinornius, a silver or silver-washed bronze coin introduced to the Roman monetary system in the early 3rd century AD, and used throughout the period of political fragmentation that followed. Every coin in the assemblage falls within the reigns of emperors, spanning a period from approximately 238 AD to no later than 293 AD. That range of 55 years encompasses one of the most turbulent periods in the history of the Roman Empire, a succession of short-lived emperors, some holding power for months before being displaced or killed, their faces pressed into the surfaces of coins that outlasted their reigns by centuries and are now the primary physical evidence that some of them existed at all. The earliest coins in the assemblage bear the image of Gordian III, who held the purple from 238 to 244 AD. Those coins recovered from within the assemblage show the wear of circulation, edges softened, portrait details slightly flattened by the repeated pressure of passing between hands over years or decades of use before the assemblage was sealed. The wear pattern is consistent with coins that circulated for a generation or more before they reached the pot. They are the oldest material in the deposit, coins that were old when the hoard was buried, coins that had already passed through many hands before they came to rest in a sealed ceramic vessel in a Somerset floodplain field. What they preserve is not just the image of an emperor, but the record of ordinary commercial movement, market transactions, wage payments, small purchases made at a distance from wherever these coins were minted. Among the 766 coins, the ones that draw the most careful attention from the numismatists who have studied the hoard are those bearing the image of Carausius. There are approximately 52 of them in the assemblage. Carausius was not an emperor of the Central Roman state. He was a military commander who declared himself ruler of a breakaway empire encompassing Britain and parts of northern Gaul in 286 AD, and who held that position until his assassination in 293 AD by his own finance minister, a man named Electus. The coins he issued during those 7 years are among the most numismatically interesting produced anywhere in the Roman world during the 3rd century. His mints, operating in Britain, likely at London and Colchester, with a third mint whose location has never been securely identified, produced coins that betray an ambition beyond mere currency. The portraits on Carausian coins are distinctive. The legends around their edges are sometimes literary, occasionally invoking lines from Virgil. Carausius understood what coins were for beyond their function as tokens of exchange. He understood them as statements. One coin in the Frome assemblage bears the legend IOV, interpreted by numismatists as an abbreviation for Iovius, a title invoking Jupiter, the chief deity of the Roman pantheon. The choice of this legend was deliberate, and its meaning was specific. By invoking Jupiter in abbreviated form on the face of his coinage, Carausius was placing his rule under divine sanction, associating himself with the highest power in the Roman religious hierarchy, making a claim not merely political, but cosmic. The coin is small. Its silver content, measured by X-ray fluorescent spectroscopy on related pieces in the assemblage, is low, below 5%. The alloy mostly copper and lead. The silver present largely as a surface wash that has darkened and thinned over 17 centuries. The ambition, the legend encodes, stands in a particular relationship to the material that encodes it. The claim to divine authority, pressed into a coin whose metal could barely sustain the portrait above it, is a record of something, not a contradiction, exactly, but a proportion that the hoard preserves in its unedited form. The 52 Carausian pieces are not uniform. They show variation in portrait style, in the quality of the die cutting, in the precision of the legends around the rim. Some are cleanly struck, the details sharp, and the portrait well centered. Others are struck from tired dies, the portrait slightly doubled, the legend running off the coin's edge where the die was not properly aligned. That variation is a record of production under conditions that were not those of a fully organized central mint. Carausius's coinage was produced in Britain by a government that had severed its connection to the central Roman monetary administration in Rome. The coins are evidence of that severing, the small material consequences of a large political rupture, visible in the quality of the die work and the composition of the alloy. The coins bearing Gordian III and the early emperors at one end of the chronological range, the Carausian pieces at the other. Between them, the hoard contains coins from the reigns of a succession of emperors, whose names are less familiar than those at either end of the sequence. Philip I, who reigned from 244 to 249 AD, Decius, who held power briefly and died in battle against the Goths in 251 AD, Gallienus, whose long reign from 253 to 268 AD is represented by multiple pieces in the assemblage, Claudius II, whose reign lasted less than 2 years before he died of plague in 270 AD, but whose coins were minted in such quantity that they are among the most common of all late Roman coin types in British hoards. Aurelian, Tacitus, Probus, Carus, and then, at the end of the sequence, the Carausian pieces that establish the latest possible date of deposit. Among the coins is one belonging to the reign of Florian. Florian held the title of emperor for approximately 88 days in the summer of 276 AD, a reign so brief that it left almost no administrative record. His coinage was struck in that brief window, and the coins that survive, scattered now across the assemblage records of dozens of hoards throughout the former Roman world, are the primary evidence that his reign occurred at all. A Florian coin in the Frome hoard is a small physical fact with a disproportionate weight of historical significance pressed into it. The portrait is there. The legend names him. The coin was made, circulated, and eventually found its way into a collection of savings deposited in a Somerset field, where it waited to be separated from its neighbors by a conservator using a wooden implement in a room in London 17 centuries later. The 88 days of Florian's reign left almost no other trace. The coin confirms the days happened. The internal environment of the ceramic vessel preserved more than the coins. Soil samples taken from inside the pot, gathered with labeled glass tubes during the excavation, each tube sealed and tagged with a context number corresponding to its precise position within the burial, yielded, on laboratory analysis, traces of degraded organic compounds. The analysis identified these compounds as consistent with plant fiber. The specific identification, based on the molecular profile of the degraded material in comparison with reference samples of documented ancient textiles, was linen or hemp, the two plant-based fiber materials most commonly used in Roman Britain for textile production. What the laboratory analysis recovered, in other words, was not intact textile. It was what textile becomes after 17 centuries in the sealed, humid microenvironment of a clay-packed ceramic vessel buried in floodplain soil. The original material had degraded beyond any possibility of structural recovery. What survived was the chemical signature of its having been there. The most likely interpretation of that organic trace is a bag or wrapping, a length of linen or hemp fabric used to bundle the coins before they were placed in the pot, or to line the pot's interior before the coins were poured in. This was a documented practice in Roman Britain. Coin hoards from the period frequently show evidence of having been contained in textile wrappings or leather pouches, the organic material degraded or lost in most cases, but occasionally preserved in the specific microenvironments that favor organic survival. The from Hoard sealed ceramic context provided exactly that kind of microenvironment. The pot's walls excluding the oxygen and biological agents that drive decomposition, the floodplain clay packing around it, forming an additional barrier. The linen or hemp lasted long enough for its chemical signature to be recoverable. The signature survived, the textile did not. A pinch of the degraded fibrous material, recovered during the laboratory analysis of the internal soil samples, now sits in a sealed glass tube in the Museum of Somerset's study collection. The tube is labeled with the context number from the excavation record. The label connects it to the full documentation of the deposit, the site drawings and soil sample logs and conservation notes that together constitute the scientific record of how the hoard was found and processed. The tube holds something that is no longer recognizable as fiber, no longer possible to examine under ordinary light as a piece of cloth or a twist of thread. It is dark material in a small sealed container. Its significance is entirely a product of what the analytical instruments found in it and what that finding implies about the hands that once touched it. Those hands packed every coin in the hoard. Whatever the linen or hemp originally was, a bag, a bundle, a wrapping folded around the stacked coins before the whole assembly was pressed down into the pot. It was in contact with each of the 766 Antoniinae at the moment of deposition. The textile and the coins and the ceramic vessel and the decision to bury them were all simultaneous. The organic trace is the only surviving fragment of a human act that is otherwise recoverable only through its material consequences. The coins, the pot, the stratigraphic position, the soil chemistry, the textile was part of the act. It touched the coins. It was placed in the vessel. It has left what it could leave, which is less than its form, but more than nothing. The disturbed scatter zone surrounding the ceramic vessel, the area of soil displaced when the pot collapsed and its contents shifted under the pressure of the overlying material, yielded 3 additional objects. They are small, greenish with copper oxide patination, irregular in shape, their original form no longer recoverable from visual examination alone. The excavation team recovered them alongside the coins in the immediate vicinity of the vessel, noted them in the site record, and bagged and labeled them separately. In the laboratory, X-ray fluorescent analysis confirmed their composition, a leaded bronze alloy, copper and lead, in a ratio consistent with late Roman military and equestrian hardware, harness fittings, strap junctions, the metal components of the equipment used with horses or worn by soldiers. The 3 fragments have been tentatively identified as parts of a harness fitting or strap junction. That identification is provisional. The oxidation has removed the surface detail that would allow a more confident attribution, and X-ray imaging did not resolve the original form clearly enough to match it to a known type with certainty. What the XRF analysis does confirm is that the fragments are not accidental inclusions, not agricultural debris from later periods, not stray metal from the overlying plow zone. Their composition is consistent with late Roman production, and their position within the scatter zone surrounding the vessel places them within the original deposit context. The most likely explanation for their presence is that they entered the pot or the area around the pot as part of the original burial, perhaps attached to the textile wrapping, perhaps included deliberately alongside the coins, perhaps simply present in the soil at the deposition point and incorporated into the disturbed scatter when the vessel collapsed. The record does not resolve this question. What the record shows is 3 fragments of a leaded bronze alloy, late Roman in composition, found in close association with a hoard of late Roman coins, and now laid side by side on a white analysis tray in the British Museum's Metals Laboratory, with a typed report beside them, recording what the instruments found when they looked into the metal. The coins themselves, separated and laid out in their conservation sequence, present a particular kind of visible history. The earliest pieces in the assemblage, the Gordian III and Philip I coins from the 240 SAD, are silver washed but retain a relatively substantial precious metal content, their surfaces showing the characteristic patination of coins that circulated widely and were handled frequently before reaching the deposit. Moving through the sequence toward the later pieces, the visible character of the coins changes. The surfaces become more matte, the color shifts. The portraits remain legible. The die cutters of the period were skilled, but the metal behind them is different in its properties, its weight slightly lower, its density slightly reduced. The difference between a coin struck in 245 AD and a coin struck in 285 AD is not dramatic when individual pieces are compared in isolation. Arranged in a sequence of 766, the change is continuous and unmistakable. X-ray fluorescent spectroscopy conducted on a representative sample of the assemblage, 40 coins selected to give coverage across the full chronological range of the hoard, produced the compositional data that makes that visual impression precise. The earlier coins, dating from the reigns of Gordian III through Gallienus, show silver content ranging from approximately 20% to approximately 40% of the total alloy. By the time of Aurelian's Reform coinage, in the early 270 SAD, the silver content in the sample pieces had fallen below 20%. The Corrosian coins at the end of the sequence read below 5%. The surface wash on those pieces, the thin silver layer applied to a copper-lead core to give the coin the appearance of a silver denomination, is visible under the conservation light as a slightly different surface tone. The wash has thinned across 17 centuries. In some pieces it has disappeared entirely from the high points of the portrait, the emperor's nose and brow, reduced to bare copper by the same gentle wear that softened the coin edges in circulation. The compositional trajectory visible in the XRF data is a record kept by the coins themselves of a monetary system under sustained pressure. Each step down in silver content represents a decision made somewhere in the administrative structure of the Roman Empire, a decision to reduce the precious metal in the coinage in order to produce more coins with the available silver supply. That decision, made and remade across 5 decades of political instability, is recorded in the metal of every coin in the Frome assemblage in the form of measurable chemical composition. The coins do not interpret this history. They simply preserve it in ratios of copper and lead and silver that the instruments read without inference, each reading a number attached to a specific piece, attached to a specific emperor's reign, attached to a specific decade of a specific century. The reconstructed ceramic vessel, the 766 coins arranged in their conservation sequence, the 3 fragments of leaded bronze, and the sealed glass tube containing the degraded textile trace together constitute the physical record of the Frome hoard. The catalog is public. The data from the XRF analysis and the soil sample analysis has been published in the numismatic literature. The coins are accessible in the Museum of Somerset's permanent Roman gallery, where the purpose-built display case holds them in their cataloged arrangement behind environmental controls that maintain the stable conditions their preservation requires. The research the hoard has generated continues as new analytical techniques and new comparative material from other hoards allow the assemblage to be understood in progressively greater detail. The conservation photographs taken during the separation process, the compacted coin mass before separation, the individual coins emerging from it one by one, the sherds of the ceramic vessel laid out on a clean surface before reconstruction, are archived and accessible. The record is not closed. What the physical inventory of the hoard preserves, laid out fully, is a set of objects that were selected and placed together by a single act of decision and then sealed. The coins span 5 decades of accumulation. The textile that wrapped them was the material the person who buried them chose for that purpose. The ceramic vessel was the container they had. The 3 metal fragments were present in the deposit for a reason that the record preserves in their position, but does not explain in its cause. The pot was sealed, buried, and covered by the soil of a Somerset floodplain field, and the specific microenvironment created by the sealing and the clay and the undisturbed burial horizon above the gravel substrate preserved the internal conditions well enough that degraded organic compounds from the textile survived in the matrix to be recovered 17 centuries later. The conservators at the British Museum, who laid the coins out in their long rows, had worked through the separation slowly and with care. The wooden implement used to free the pressed faces of the coins from one another, a tool chosen because wood is softer than the metal it contacts and will not mark the coin's surface, was narrow enough to work in the gap between 2 coins, pressed flat together across 17 centuries of pressure. The separation of each pair required attention to the way the coins had fused, not chemically bonded, but mechanically interlocked by the mineral deposits that had migrated through the matrix and settled in the microscopic spaces between the surfaces. The work was methodical. The conservators moved through the assemblage in documented order, each coin separated and numbered before the next was freed. The sequence in which the coins were separated was recorded because the sequence itself was data, the position of each coin within the stack, a potential indicator of the order in which they had been placed. When the separation was complete and the coins were arranged on the padded table, the room held something that had not been visible as a single coherent assemblage since the ceramic vessel was sealed and lowered into the ground. Gordian 3 at one end of the table, Carausius at the other, and between them the procession of short and long reigns, the ordinary and the marginal, the coins of emperors who held power for decades, and the coin of Florian, who held it for 88 days, 3 fragments of leaded bronze, the sherds of a 2-liter ceramic pot, and somewhere in the conservation suite, in the sealed glass tubes of the soil sample series, the chemical signature of a length of linen or hemp that had once touched every surface in the assemblage and was now reduced to its molecular trace, recoverable by instruments and recorded in a typed report and preserved in a labeled container alongside the other materials recovered from the ground beneath a Somerset field near the River Frome. The hoard was complete. The inventory was closed. What the padded table held was everything that had been placed in the ground, not as it was placed, the tight stack of coins inside the wrapped bundle inside the sealed pot, but laid open and examined and documented. The examination was done. The documentation was finished. The objects were ready to move from the conservation suite toward their permanent home, toward the display case and the study collection and the archival drawer. The degraded textile trace in its sealed glass tube is the object in the assemblage that holds the most direct connection to the hands that made the deposit. The coins circulated before they were buried. They passed through many hands between their minting and their placement in the pot. The ceramic vessel was made in a workshop and used before it served as the hoard's container. The metal fragments, whatever their origin, have a history that precedes the burial, but the textile, the linen or hemp wrapping that was cut or torn or folded to fit around the coins before the whole assembly was pressed down into the vessel, was shaped specifically for the purpose of this burial. It was the last thing added before the pot was sealed. It was in contact with every coin at the moment of deposition. It has left what it could leave, not its form, not its color, not the texture of its weave, but the chemical fact of its having been there, preserved in the dark interior of a sealed ceramic vessel, buried in the wet clay of a floodplain soil horizon, waiting through 17 centuries for instruments sensitive enough to find it, and for the question that would make its finding matter. What the hoard contains in full is 766 coins, and the record of their making, the reconstructed vessel that held them, 3 fragments of associated metalwork, whose function the record suggests but cannot confirm, and the material trace of the wrapping that touched them all. That is the inventory. Each object in it has been documented and analyzed and published. Each object preserves, in the specific physical fact of its composition and condition and position, something that would not otherwise have survived the 17 centuries between the act of burial and the act of recovery. The pinch of degraded linen in its glass tube is the smallest and the most fragile of those survivals. It exists because the pot sealed cleanly, because the floodplain clay packed tightly around it, because the burial horizon above the gravel substrate remained undisturbed, because the soil samples were taken from the correct positions during the excavation, and because the laboratory instruments were sensitive enough to find what the samples contained. Remove any one of those conditions, and the textile trace is lost. It survived because the conditions for its survival were all present simultaneously in a sequence that held from approximately 290 AD to April 2010 in the ground beneath a field near the River Frome in Somerset. In the dark interior of a pot that had been packed with coins and sealed and lowered into the earth by hands that included, among what they touched, a length of linen or hemp that would outlast them by the better part of 2,000 years, reduced to its chemistry, still present, still inside its labeled vial, in a sealed container in the Museum of Somerset's study collection, which is where it rests now, in the dark of an archival drawer that holds all that the hands left behind. At the British Museum's Numismatics Laboratory, on a morning in the autumn of 2010, a specialist set a single coin on a padded analysis tray and wrote 4 digits into a site record. The coin was a silver-washed Antoninius. Its portrait face showed a man who had declared himself Emperor of Britain. The date written beside it, 293 AD, marked the latest point at which the coin could have been made, and therefore the earliest point at which the pot containing it could have been buried. A single entry in a site record. The window closed at one end, and the work of understanding what lay inside it began. That process of understanding moves through several kinds of evidence, each one arriving at the same answer from a different direction. A radiocarbon reading, a spectrometer's output curve, a cross-section drawn by hand on graph paper in a Somerset field, a storage tray from a museum in Wiltshire. Each one speaks independently, and what each one says is consistent with what the others say, and the consistency itself is a form of knowledge that took time and careful attention to build. The record does not have a gap at its center. It has a date range, narrowed from several directions, and within that range, a buried season that paleoenvironmental analysis has since made specific enough to feel almost tangible. The numismatist's pencil note in the margin of a laboratory report that Autumn read, in the ordinary shorthand of the discipline, consistent with numismatic TPQ. TPQ is the abbreviation for terminus post quem, the point after which the pot must have been buried. No coin in the assemblage was minted later than 293 AD. That is the wall the date cannot pass. Everything the other methods confirmed was enclosed within that boundary, and the boundary itself was established by the single latest coin in a sequence of 766, held between gloved fingers under a conservation light in a London laboratory, while a specialist looked at the portrait of a man who had been dead for 17 centuries and wrote down what the coin's surface had preserved of the date of his making. The radiocarbon determination arrived from a different direction entirely. Inside the ceramic vessel, alongside the compressed coin mass, laboratory analysis had identified degraded organic compounds, plant fiber, most likely linen or hemp, the remnant of whatever textile had been used to bundle the coins before they were sealed inside the pot. That fiber, once separated and prepared for analysis, yielded a calibrated date range, the probability curve, printed on the laboratory report and spanning the years 220 to 310 AD at a 95% confidence level, drew a shallow bell shape across the page. Its peak fell within the same decades the coins themselves indicated. The radiocarbon date did not contradict the numismatic date. It confirmed it from a different material through a different scientific process, using a fragment of something organic that had not been expected to survive at all. And the quiet fact of that survival, that a scrap of ancient textile had endured, sealed inside a ceramic vessel, long enough to be carbon dated and read, is one of those details the record offers without emphasis, as though it were ordinary. The shape of the probability curve on that printed report has a particular quality worth dwelling on. A calibrated radiocarbon date is not a single point. It is a range of probability, the curve rising and falling across a span of years, indicating that the material being dated is most likely from somewhere within that range, with confidence diminishing at the edges. The curve printed for the from Hoard's textile fiber rose across the early decades of the 3rd century and fell again through the early decades of the 4th, its highest point coinciding with the final decades of the 3rd century, the same decades the coins indicate, the same decades that the historical record identifies as the period of Carausius, of breakaway empire, of the monetary conditions that the coin's own metal composition displays so clearly. The curve did not need to be interpreted. It simply arrived at the same place the other evidence had already reached. X-ray fluorescent spectroscopy offered a third kind of confirmation, and one that carries within it a visible record of the Roman Empire's slow material deterioration across the decades the Hoard spans. The technique works by directing a beam of X-rays at a coin's surface and measuring the characteristic fluorescence emitted by each element present, copper, silver, lead, producing a compositional profile that reveals exactly what proportion of each metal the coin contains. A representative sample of 40 coins from the Frome assemblage was analyzed this way. The results followed a trajectory that specialists in late Roman coinage would recognize immediately, and that the numbers make precise. The earlier coins in the assemblage, those dating to the reigns of Gordian III and his contemporaries in the 230 sephs and 240 sephs, showed silver content in the range of 20 to 40%, substantial silver. A coin that still carried in its metal the residue of an empire that, while already under pressure, retained enough fiscal coherence to strike currency with genuine precious metal content. Moving forward through the assemblage, through the reigns that followed, Philip, Decius, Gallus, Valerian, Gallienus, the silver readings fell, not dramatically in any single step, but persistently, decade by decade, the percentage diminishing as the empire's financial resources were drawn down by military expenditure, by external pressure on multiple frontiers simultaneously, by the compounding difficulty of maintaining a monetary system that depended on silver, the treasury increasingly could not supply. By the time the analysis reached the Corrosian coins, those struck in the decade after 286 AD, by the man who had declared himself emperor of a separate British realm, the silver reading fell below 5%. The coins still bore the form of Antonina. They still carried the portrait convention and the reverse imagery of imperial currency. Their physical dimensions had not changed dramatically from their predecessors. What had changed was the metal beneath the surface wash, now a copper-lead core, given the faintest coating of silver or silver wash, a material that the spectrometer's output graph rendered as a reading near the bottom of the scale. The graph, displayed on a monitor inside the British Museum's analytical laboratory, showed the plotted readings of all 40 sampled coins arranged in order of date, and the descending line they formed was unhurried and even the visual record of a process that had taken place across half a century of imperial history and was now recoverable from the chemistry of 39 small discs of degraded metal laid out on an analysis tray. A Corrosian coin held under a conservation light has a particular appearance that the XRF result explains. Its surface is darker than the earlier coins in the assemblage. Its finish is more matte, less reflective. The silver wash, where it survives at all, appears in patches rather than as a uniform coating, and the copper-lead core shows through in the spaces between. The coin does not look impoverished. Exactly. It looks as though the material from which it was made was working hard to maintain an appearance the underlying composition could no longer fully support, which is, the spectrometer confirms, exactly what was happening. The high-laid content recorded in the Corrosian coins shows in the patination as a particular quality of darkness, a heaviness in the surface tone that distinguishes them from the earlier silver-bearing coins, even before analysis. The metallurgy and the appearance agree with each other, and both agree with the historical and numismatic record, and all of it is present in the objects themselves, recoverable by instruments and by careful eyes. The stratigraphic evidence arrived from yet another direction, not from the coins or their material, but from the ground that had enclosed them for the centuries between their burial and their recovery. In the field records made during the excavation, the burial horizon was designated Context 003. The site drawing of that context, rendered in careful cross-section on graph paper, in a field archaeologist's hand, shows a layer of mid-brown silty clay lying above a gravel substrate and below the mechanically disturbed plow zone that the agricultural work of recent decades had created across the upper portion of the profile. The ceramic vessel's outline is marked at the center of the Context 003 layer, its position recorded with the precision a site drawing requires, depth, orientation, the spatial relationship to the layer boundaries above and below. The significance of that stratigraphic position lies in what was not found within a 2-meter radius of the vessel. No medieval material, no post-Roman material, nothing in the surrounding matrix that post-dated the late Roman period. In stratigraphic terms, the layer had not been disturbed since the coins were placed within it. Whatever had happened to the landscape above, the shifting of agricultural land use across the medieval and post-medieval centuries, the gradual plowing down of the soil horizon that had once sealed the deposit more deeply, the burial layer itself had remained intact. Context 003 had held. The clay had compressed around the ceramic vessel and the coins within it, and the moisture levels maintained by the floodplain geology had created the sealed microenvironment in which the coins survived their 17 centuries in notably fine condition. The cross-section drawing on graph paper recorded all of this as a series of labeled lines on a sheet, quiet and precise, the field record of a buried world that had waited, undisturbed, for the detector's signal. Below context 003, the drawing labels the natural gravel substrate as context 005. The two layers are separated on the drawing by a line that represents the contact between the silty clay of the burial horizon and the river-deposited gravels beneath it, gravels laid down by the river Frome across centuries of floodplain activity that predated the Roman occupation of the valley. Entirely within that gravel substrate, during the soil sampling that accompanied the excavation, the team recovered molluscan remains, shells of small freshwater and wetland snails, preserved in the mineral-rich gravel environment. The species assemblage identified in those shells is consistent with a wet, marshy floodplain, slow-moving water, reed margins, the kind of low-lying, seasonally inundated landscape that the paleoenvironmental reports describe as the character of the Frome Valley before the drainage and agricultural improvement of more recent centuries remade it. Those shells are not from the Roman period. They predate the Hoard by centuries or millennia, their deposition part of the long floodplain history of the river valley, rather than any event connected to the coins above them. But their presence in the record matters because of what they establish about the place. The ground in which the Hoard was buried was, in its deeper layers, a record of an environment, wet, marginal, subject to seasonal flooding, that the gravel composition and the molluscan fauna together describe. The burial was made into a specific kind of landscape, one whose physical character the geological record preserves beneath the anthropogenic layers above it. The shells in context 005 are the ground remembering what it was before anyone buried anything in it, and that memory is part of the full record of the Hoard, even though it predates the coins by epochs. The Frome Hoard does not exist in isolation within the British archaeological record. It takes its place within a pattern of late Roman coin hoards concentrated across the decades between approximately 270 and 320 AD, a group that includes assemblages from Wiltshire, from Lincolnshire, from across the provinces of Roman Britain, all sharing a recognizable profile of coin types and all terminating in the same late Corrosian or early post-Corrosian period. The pattern is not coincidental. It reflects a specific historical moment in which the conditions for burying coins and not returning for them were widespread across the island, concentrated in the same decades, and associated with the same coin types and denominations. The Conesio Hoard, recovered from Wiltshire in 1978, contained 54,951 coins, a number so large that the assembly of its catalogued coin types in museum storage occupies a tray arrangement that makes the parallel with the Frome assemblage immediately visible. The same Antoniniani, the same terminal date range, the same compositional trajectory from silver bearing to largely debased. The Norman B. Hoard, recovered from Lincolnshire in 1985, contained 47,912 coins and shares the same profile. These are large assemblages, and the Frome Hoard is a smaller one, but the coin type profile that all three share, the sequence of reigns, the compositional decline, the terminal date in the Corrosian period, is the same pattern expressed at different scales, and the pattern's consistency across the three finds is itself a form of evidence about the period in which they were all buried. A museum storage tray holding the Conetio Hoard's catalogued coin types in reference rows is a physical object that demonstrates this parallel without requiring interpretation. The Frome Hoard's coin types, arranged in the same order on their own conservation table, would produce the same sequence. The two assemblages, separated in discovery by 32 years and in find spot by tens of miles, speak with the same numismatic vocabulary because they were assembled during the same historical period by people living under the same monetary conditions. The pattern in the reference tray is not imposed by the analyst. It is recovered from the objects themselves, and the objects confirm each other. The terminus post quem established by the Corrosian coins, no burial before 293 AD, does not tell the full story of the date range the evidence supports. It establishes the floor. The ceiling requires a different kind of reasoning. The latest Corrosian coins in the assemblage date to no later than 293 AD, the year of Carausius's assassination. After that year, no further Corrosian coins would have been minted. If the hoard were buried significantly after 293 AD, it would likely contain coins of Electus, the man who succeeded Carausius, or coins of Constantius Chlorus, who reconquered Britain in 296 AD. The Frome assemblage contains neither. The absence of Electan or Constantian coins does not prove the hoard was buried before 296 AD. Absence of evidence is not evidence of absence in numismatics, but it is consistent with a burial date close to the terminal point of the Corrosian coinage, and inconsistent with a burial significantly later. When all three evidential streams, the radiocarbon result, the numismatic terminus, the stratigraphic confirmation, are placed alongside each other, the window they collectively define is approximately 270 to 310 AD, with the numismatic evidence pointing most specifically toward the late Corrosian period as the moment of deposit. The radiocarbon range is wider, as radiocarbon dates for this period tend to be, the calibration curve for the late Roman centuries being less precise than for earlier or later periods due to the shape of the atmospheric carbon record. But its peak falls within the narrower numismatic window, and the stratigraphy confirms that the deposit was not disturbed after it was made. Three kinds of evidence, each generated by a different analytical method from a different type of material, arriving at the same decade. The record shows this not as coincidence, but as the normal result of careful analysis applied to a well-preserved deposit from a period whose material culture is well understood. There is a quality to this kind of convergent dating that is worth sitting with quietly. Each individual method carries its own uncertainty. The radiocarbon curve has its calibration limits. The numismatic TPQ is a floor, not a point. The stratigraphy establishes undisturbed condition without giving a year. No single method would be sufficient on its own to produce the confidence the combination achieves. But placed together, three independent lines of evidence pointing to the same decade, the uncertainty of each individual method is reduced by the consistency of the others. The result is not a single date. It is a range with a center of gravity, a cluster of probability, dense enough to support the understanding that sometime in the approximate decades between 280 and 310 AD, someone in the Frome Valley dug a hole in a silty clay floodplain, placed a ceramic vessel into it, and did not come back. The XRF composition data, the calibrated radiocarbon probability curve, the site cross-section labeled Context 003. These are documents of a specific kind. They are the means by which a deposit that survived without documentation for 17 centuries becomes readable to the methods of the present. The coins themselves are primary evidence, but the coins without the analytical records are harder to place with confidence. The analytical records transform the coins from objects into a dated assemblage, from things found into things known. That transformation is the work of the laboratory, the field archaeologist's drawing, the specialist who writes a date range into a margin and checks it against what the spectrometer has confirmed. And the process is slow and unhurried and exactly as careful as the deposit deserved. A single coin of Florian, emperor for only 88 days in 276 AD, the reign too short to leave much behind in the material record of the period, was present among the separated assemblage. Its existence in the hoard marks an interval so brief that numismatists have always found Florian's coins scarce. 88 days of minting, a reign measured in weeks rather than years, ending in a manner the ancient sources describe, in terms that suggest the brevity was not accidental. The coin does not tell the hoard's owner anything they would not have known. A coin passes through hands without recording the faces of those hands. But its presence in the assemblage places within the deposit a material record of a reign that left almost nothing else behind in the ground, and the laboratory that separated it from the compressed coin mass in which it had spent 17 centuries created, in the act of recovering it, a record of its survival that will outlast any single institution or any individual who holds it. The site drawing of Context 003 sits now in a site archive. The graph paper is precise and slightly faded, the pencil lines of the cross-section still clear, the labels for the burial horizon and the underlying gravel substrate, and the overlying plow zone still legible in a field archaeologist's careful hand. The ceramic vessel's position is marked at the drawing's center. The 2-meter radius within which no later material was found is indicated by the absence of annotation in the surrounding zone, the blank space of the drawing carrying its own meaning, the silence in the record confirming what the deposit's condition confirmed separately. On the monitor in the British Museum's Analytical Laboratory, the XRF spectrometer's output graph plotted the silver content of 40 representative coins in descending order of date, a declining curve drawn across the range of the assemblage. From the 20 to 40% readings of the earliest coins to the sub 5% readings of the Corrosian pieces at the end of the sequence. The threshold line at 5% is a reference mark, not a judgment. The coins below it are not inferior objects. They are accurate material records of the monetary conditions under which they were produced, and those conditions are part of the history the hoard preserves. A Corrosian coin held between two gloved fingers under a conservation light reads its own debasement in its surface tone and its weight, and the spectrometer confirms what the hands and eyes have already noted, the metal openly recording the conditions of the empire that made it. The radiocarbon laboratory report folded into the site archive carries the probability curve on one side and the typed summary on the other. The calibrated range, 220 to 310 AD at 95% confidence, is printed in the summary table. The pencil annotation in the margin, consistent with numismatic TPQ, was written by whoever reviewed the result against the coin evidence. The two determinations checked against each other in the ordinary way, and the agreement noted without ceremony, as the record does not require ceremony to establish what it establishes. All of this, the XRF curve, the radiocarbon table, the site drawing, the margin note, is the means by which the hoard was placed within the sequence of its own period. The coins were objects first and evidence second, and the analysis made them evidence without changing what they are as objects. The Corrosian coin with its matte dark surface and its sub 5% silver content is still a coin, something made by a hand, struck in a die, passed from hand to hand through a late Roman world, and it is also now a data point in a spectroscopic profile and a contribution to a terminal date range and a record in an institutional catalog. The two kinds of existence do not contradict each other. The object holds both, and the archive holds both, and the range of dates the evidence supports is specific enough to locate the burial within a recoverable historical moment, while remaining honest about what the methods can and cannot confirm. Below context 003, in the natural gravel substrate that the site drawing labels context 005, the molluscan assemblages wait in the archive alongside the soil samples and the radiocarbon preparations. The shells are small and unspectacular. They are the type of freshwater and wetland snail that colonizes the margins of slow-moving water, the kind of wet, reedy landscape that the floodplain of the River Frome represented in the centuries before Roman occupation and continued to represent in modified form during the Roman period. Their presence in the gravel confirms the paleo-environmental character of the valley, the seasonal flooding, the silty deposition, the particular dampness of the ground in which the ceramic vessel sat for 17 centuries, and in which the coins maintained the notably fine condition that the conservation team recorded when the assemblage was separated. The gravel that holds the shells was laid down by the river across a period that predates the Hoard by far more than the Hoard predates the present. The river built the substrate on which the burial was made, deposited the silty clay in which the burial was enclosed, and continued to adjust its course across the centuries that followed. The ground remembers all of this in layers: the fluvial gravel of an ancient active channel, the silty clay of a quieter overbank environment, the disturbed plow zone of the agricultural centuries above, and context 003, the burial horizon, sits within that layered memory at a specific depth, with specific material above and below it, and the cross-section drawing records its position with the precision that field archaeology exists to establish. The numismatist's margin note, the spectrometer's declining curve, the radiocarbon probability table, the cross-section labeled in pencil on graph paper, the molluscan assemblage in its labeled sample bags. Each one is an independent document generated by a different method held in a different part of the archive, and each one, read against the others, confirms what the others say. The window the evidence defines is approximately the same from whichever direction the analysis approaches it. Someone buried the pot in the silty clay of the Frome floodplain in the approximate decades around the end of Corrosian Britain, and the ground held it, and the coins held their portraits and their inscriptions in their declining silver content, and the textile fiber held enough of its carbon to be dated, and the shells in the gravel below held the memory of the wet landscape that had been there long before any of it, and all of it waited, undisturbed, in the sealed darkness below the plow zone, until the detector's signal registered a strong reading in the gray April light, and a careful person stopped and put down the machine. The natural gravel substrate of context 005 has not been moved. It remains below the burial horizon, in the ground near the River Frome's floodplain edge, the molluscan assemblages within it, still in their matrix, still recording the wet and marshy character of a Roman Somerset that drainage and agriculture have remade beyond recognition above them. The site drawing marks the contact between context 003 and context 005 as a single line across the cross-section, the boundary between the world the Hoard inhabited and the deeper world the river built beneath it, the place where the human deposit meets the geological deposit, where the coins rest on the gravel that the river laid down centuries before anyone thought to bury anything in the valley at all. That line on the graph paper is a quiet thing. Below it, the ground holds what the river gave it. Above it, the silty clay held what a person placed within it, sealed it, and left. And below the coins, and below the textile, and below the ceramic sherds, and below the silty clay of the burial horizon, the gravel of context 005 continues to hold the shells of the wetland snails that lived in the river margins of a Roman floodplain, each one a small, patient record of the water and the reeds and the soft seasonal flooding of a landscape that has long since drained away, but that the ground has not forgotten, and that the archive now has made available to anyone who wants to read it. The Frome Valley in the early 290s AD is recoverable from the ground itself, if the ground is read carefully enough. Paleoenvironmental analysis of the floodplain deposits, the pollen columns, the insect assemblages, the waterlogged plant, macrofossils, describes a landscape that was flat and seasonally wet, edged to the south and east by the long ridge of the Mendip Hills, crossed by a Roman road that ran as a raised causeway above the level of the winter flooding, and threaded throughout by the quiet lateral movement of the river itself. The morning that matters in this story is a late spring morning, the kind that the pollen record of the buried vessel's interior matrix confirms in its way. Grass pollen, flowering plant traces, the biological signatures of a landscape in its warmer season rather than its bare one. Someone was in that landscape with a ceramic pot and a decision to make, and the ground held everything they left behind. The Mendip Hills rose to the south as they rise today, though the vegetation covering them in the late 3rd century would have been managed and worked, the slopes carrying the evidence of 2 centuries of intensive Roman extraction. Lead was the Mendip's primary yield in this period, and the scale of the industry was significant enough to leave its mark in the sedimentary record of lakes far to the north, where pollution signatures from Roman-era Mendip smelting are still recoverable from dated core samples. The lead went outward from the hills in ingots, each one stamped with the mark of the imperial authority that supervised the mine's output, the emperor's name pressed into dull gray metal as a kind of claim, a reminder that the wealth of the ground passed first through the machinery of the state before it became a commodity anyone could trade with. Those ingots moved through the Frome Valley. The road that carried them connected the Mendip mining district to the Bristol Channel ports, to the west and to the inland network beyond, and the Frome area sat at a point in that commercial corridor where movement through the landscape was a daily and ordinary fact. The Fosse Way, the great Roman road that still runs as a recognizable earthwork across parts of Somerset, passed not far from this region, its straight line cutting across the natural contours of the land in the characteristic Roman way, different to the gentle irregularities of a terrain it simply overrode. Bath lay to the east along the road network, Aquae Sulis, the spa city built around the sacred spring that had been a place of religious significance before the Romans arrived and continued to be one long after the empire consolidated. The spring at Bath is the most abundantly documented case of votive deposition in Roman Britain. Thousands of coins were cast into the sacred waters there as offerings to the goddess Sulis Minerva, whose authority presided over the hot water rising from the ground. And the practice of giving wealth to water, of placing something valuable into the keeping of a river or a spring as an act of deliberate, permanent separation, was not confined to Bath. The archaeological record of Roman Britain contains examples of deliberate waterside deposition from across the period and across the landscape. Coins appear in river margins, objects appear in bog edges. The boundary between water and land was, in the Roman understanding, as in the earlier Iron Age understanding, a threshold that carried meaning, a place where the worlds adjacent to ordinary life were close enough to receive what was offered, whether the from Hoard represents an offering or an emergency, or something that holds elements of both in proportions that can no longer be separated. The record does not establish. What it establishes is the proximity of floodplain margin, a river whose name is older than the Roman occupation of Britain, and a ceramic vessel buried at the point where ordinary ground gave way to the seasonally inundated soil of the waterside. The choice of location, whatever its specific intention, was not random. Floodplain edges were known places, places with names and associations, and the accumulated memory of everything that had been done there before. Someone who chose this particular ground chose it within a world that understood ground as something that remembered. The political circumstances of the period 290 to 305 AD, the window within which the Hoard's latest coins and the palo-environmental traces together place the burial, constitute a kind of ambient condition rather than a specific event. The coins bearing the name and portrait of Carausius are the Hoard's most numerically unusual feature. Approximately 52 of the 766 coins carry his image, a proportion that suggests deliberate collection or long local familiarity with his currency rather than incidental accumulation. Carausius had declared himself Emperor of Britain and the northern coast of Gaul in 286 AD, a military commander who redirected the loyalty of the fleet under his command toward his own authority and held a separate empire for 7 years before his assassination in 293. His coins were issued from mints in London and elsewhere, and they circulated in Britain during his reign with the full weight of an issuing authority behind them. The coins were real currency, used in real transactions, accepted in real markets. A person who accumulated Carausian coins over those 7 years was not doing anything unusual. They were simply living in the economic world available to them, the world where Carausius's portrait was the face of legitimate authority. His assassination changed the denomination of that legitimacy. The finance minister Electus, who killed Carausius and took his position, issued his own coins, and 3 years later, the reconquest of Britain by Constantius Chlorus in 296 AD changed the denomination again, bringing Britain back within the orbit of the Central Empire and the central currency system. What happened to the purchasing power and legal standing of Carausian coins in the years after 293 is not a matter the sources address with precision, but the practical consequence of political reintegration is that currency issued by a now delegitimized authority acquires an uncertain status. It may still circulate by convention, by weight, by the inertia of established commerce, or it may become a liability, a thing that marks its holder as having transacted within a political order the current authority has repudiated. The hoard contains no coins dated after the Carausian period. The terminal point of its accumulation coincides exactly with the period of maximum political uncertainty for anyone whose financial life had been conducted within Carausian Britain. None of this establishes that the burial was an emergency. The pollen record, with its traces of grass and flowering plants, suggests a late spring or early summer morning rather than a winter flight from any particular danger. A person burying valuables in genuine panic does not necessarily choose the warmer season, but a person burying valuables as a form of considered long-term storage, placing savings in the ground against a future need, might well do so in reasonable weather, during a working day, in the ordinary course of managing a life that had become more complicated than it recently had been. The ground was a form of holding, The ceramic pot was a form of vault, the choice of a floodplain margin beside a river that the paleoenvironmental record shows was actively moving and periodically flooding, introduced a specific kind of obscurity into the deposit. The ground near rivers changes, accumulates, shifts, that may have been calculated as much as it was convenient. The total value of 766 Antoninian, coins equivalent in their period to several months' wages for a Roman legionary soldier, places this hoard within the financial range of the middling figures of late Roman provincial life. It is not a great treasure in the sense of something that belonged to a very wealthy house or a military paymaster or a civic treasury. The coin date range spans approximately 50 years, from the reign of Gordian III in the late 230 Seth through the Corrosian issues of the late 280 Seth and early 290 Seth and early 290 Seth. And that spread across 5 decades is consistent with gradual accumulation, the pattern of savings added to incrementally rather than assembled all at once. A single large commercial transaction, a payment received for a cargo or a contract, might produce a single coin type or a narrow date range. Coins gathered across 50 years come from an ongoing economic life, from transactions conducted over time, from the slow accumulation of a working person's financial reserves. Someone saved these coins the way that most savings are assembled, a little at a time, across a life. The figures who populated the Frome Valley's economic life in this period are accessible only through their material traces and through the broader documentary record of late Roman Britain's social structure. A property-owning farmer managing an estate on the floodplain edges, where the seasonally rich alluvial soil supported productive agriculture, would have had occasion to accumulate surplus over time. A merchant who moved goods along the road, connecting the Mendip mines to the Bristol Channel ports and eastward toward Bath, would have handled coin regularly and retained a portion of it. A military veteran settled in the Southwest after service might have carried savings through a career and added to them in civilian life, in a region where the Roman presence in the form of roads, towns, and the organized mining industry had made commerce a normal condition of existence for generations. An estate manager overseeing the agricultural operations of an absentee landlord might have controlled significant sums on behalf of a household without owning any of it outright, though the act of bearing suggests possession sufficient to make the decision independently. Any of these profiles fits the material evidence. None of them can be confirmed. What the record does confirm is the root of connection that made the Frome Valley a coherent place to have accumulated coin in the first place. The lead industry in the Mendips was not merely a local economic engine. It was integrated into the imperial supply system, producing metal that moved outward through a distribution network extending well beyond Britain. The management of that industry, the payment of workers and contractors, the taxation of output, and the commercial flows it generated, all involved coin moving through the hands of people at multiple levels of the operation: supervisors, transporters, merchants, landowners whose estates supplied the workforce, and the workforce itself. The road through the Frome Valley was part of that system's circulatory structure. Coin entered the local economy through the industry and its associated commerce, and settled, over time, into the savings of the people whose working lives were organized around it. The river moved through this economy as a geographic fact that shaped it. The Frome's floodplain set the terms of the agriculture on either side: the winter inundation that enriched the soil, the spring drainage that permitted planting, the summer's productive period that the pollen record of the Hoard's interior matrix records in its gentle, specific way. a working life organized around the agricultural calendar of the Frome Valley would have known this sequence as fundamental: the wet season's constraint, the dry season's opportunity, the annual rhythm of a landscape shaped by water's seasonal authority over the low ground. The late spring morning that the pollen traces suggest was not an unusual morning in that landscape. It was the kind of morning that came every year, when the ground was workable and the valley was productive and the season was at its most generous. Someone walked out into it with a ceramic pot containing the accumulated savings of decades, found a place at the floodplain margin near the water, and put the pot in the ground. The organic traces that the laboratory identified inside the vessel, degraded compounds consistent with linen or hemp textile, indicate that the coins were not simply poured loose into the ceramic container. They were wrapped or bundled in fabric. The individual coins, or groups of coins held in cloth before being placed together inside the pot. This is a detail of care. It suggests a person who was attentive to the preservation of what they were burying, who took the step of wrapping the coins rather than simply dropping them in, as though the wrapping offered some additional layer of protection or organization against the time they intended to leave the deposit undisturbed. The fabric has not survived. The organic compounds that the laboratory identified as consistent with plant fiber are what remains of the cloth after 17 centuries of ground chemistry have reduced it to traces perceptible only at the molecular scale. But those traces are sufficient to confirm that someone handled this deposit carefully before closing the pot. The ceramic vessel itself, approximately 2 liters in capacity, dark-fired, of a type consistent with late Roman domestic production, was the kind of container that would have been unremarkable in the household or market of its period. It was not a special object made for the purpose of being a vault. It was a pot, the kind of vessel that held food or stored liquid or served some ordinary function in a working domestic economy, and it was repurposed for this burial in the way that practical people repurpose ordinary things for uses that lie outside their original design. The coins packed tightly enough to fill it close to capacity, their combined weight of approximately 785 kilograms pressing against the ceramic walls through the linen wrapping, the pot sealed or covered, though the manner of its sealing has not been recovered. The vessel's collapse having disrupted whatever closure protected the interior, and placed in the ground at a depth of approximately 30 centimeters below what was then the surface of the floodplain. 30 centimeters is not deep. It is the depth of a careful burial, rather than a desperate one, deep enough to place the pot below the zone that would be disturbed by plowing or animal activity, shallow enough to be recoverable without significant effort by someone who knew where to look. A person burying savings for long-term keeping rather than permanent concealment might choose exactly this depth, enough to protect the deposit from casual surface disturbance, not so deep as to make retrieval difficult for someone returning with the right information. The depth implies intent to return. It implies a burial that was meant to be a temporary measure, a form of holding, a way of securing what could not at that moment be safely kept in an accessible place. The fact of the deposit's recovery in 2010 establishes that the return did not happen. The ground kept what was placed in it, beyond the period of the depositor's access to it, for reasons the record does not supply. The 3 copper alloy fragments recovered from the scatter zone surrounding the vessel, tentatively identified as parts of a harness fitting or strap junction, their original form too degraded for confident reconstruction, introduce a detail that the record leaves open. They may have been in the vicinity of the burial by coincidence, deposited at a different time by a different process. Their proximity to the hoard, the result of the soil's general accumulation of material, rather than any deliberate association with the ceramic pot. They may have arrived there with the person who buried the coins, carried as part of the equipment of a journey made on horseback, or with a horse-drawn vehicle, lost or discarded at the moment of burial without intent. The X-ray fluorescence analysis confirms they are a leaded bronze alloy consistent with late Roman military or equestrian hardware, which places them within the material culture of the period and the region, but does not place them within any more specific narrative. 3 small greenish fragments on an analysis tray, their surface detail gone, their composition recorded, their story closed at the point where the chemistry stopped speaking. The road that ran through the Frome Valley as a raised causeway across the floodplain would have been visible from the burial site, not necessarily from the exact point of the trench, but from the surrounding ground, the landscape of the deposit's immediate context. Roads in the Roman provincial world were public infrastructure, but also social architecture. They carried military movement, commercial traffic, official communication, and the ordinary mobility of people whose working lives required movement between settlements, farms, markets, and the industrial sites that generated the commercial flows. The roads were built to serve. A person choosing a burial site on the floodplain margin would have known the road's location as a navigational reference, a landmark by which the deposit's position could be remembered and described. The river was another such reference, perhaps the more durable one. The road could be repaired or rerouted, but the river held its course within the range of its natural meander, and the relationship between the bank and the burial site was a spatial fact that would persist across a season of absence. The sacred significance that waterways carried in the religious landscape of late Roman Britain is woven through the archaeological record in ways that resist clean separation from the practical reasons that floodplain margins might be chosen for concealment. The votive practice documented at Bath, coins, curse tablets, personal objects cast into the sacred spring with deliberate intent, represents the most elaborate British expression of a religious relationship with water that extended across the Roman period and before it, continuous with the Iron Age practices of depositing valuables in rivers, bogs, and lake edges as offerings to the presences believed to inhabit those boundaries. The Frome had its own character as a watercourse, its own relationship to the communities that lived along its banks, and used it for the practical purposes of drainage, water supply, and boundary marking. Whether that relationship carried a specifically religious dimension at the Frome's floodplain margins in the period of the Hoard's burial is not something the record establishes. What it establishes is the ambient context. The practice was known, the logic was available, and the choice of a waterside location for the deposit of valuables fit within a landscape of meaning that the people of late Roman Somerset inhabited as naturally as they inhabited the physical geography. The Mendip Hills on the southern horizon of the Frome Valley were not merely an economic resource in the late Roman period. They were a landscape that had been worked and marked and understood for centuries, carrying the accumulated significance of the mining operations, the settlements that supported them, the roads that connected them to the wider network, and the long pre-Roman history of human activity that the Roman occupation reorganized without erasing. The lead-stamped ingots moving through the valley were part of a chain of production and distribution that tied this quiet agricultural floodplain to the economic metabolism of an empire that extended from Britain to the eastern Mediterranean. A person living and working in the Frome Valley in the early 290s AD was, in that sense, embedded in something much larger than the local landscape, connected through the road, through the currency, through the commercial and administrative structures of Roman Britain, to a world of institutional reach that was, at that precise moment in history, reorganizing itself in ways that were not yet legible from the ground. The reconquest of Britain by Constantius Chlorus in 296 AD, the military campaign that ended the Electon regime and returned Britain to the Central Empire's political authority, would have been felt in the Frome Valley not as a dramatic event, but as a gradual shift in the conditions of daily economic life. The currency changed its face. The administrative structures adjusted. The commercial flows that moved through the Fosse Way and the Mendip roads continued, because the infrastructure that supported them was real and durable and served the new authority as well as it had served the old one. But the accumulated savings of someone whose economic life had been conducted during the Corrosian period now existed in an altered context, and the decision about what to do with that wealth, keep it, spend it, convert it, or put it somewhere safe, while the new arrangements became clear, was a decision that had to be made in the ordinary conditions of a late spring morning, in a landscape that looked the same as it had always looked, with coins that carried the face of an emperor who had been dead for 3 years. The pollen record preserved inside the ceramic vessel holds that morning in its own way. Grass pollen and the traces of flowering plants, the biological output of a landscape in its productive season, settled into the soil that surrounded the pot at the moment of its burial, and the sealed interior environment of the vessel captured enough of that material to survive 17 centuries of ground chemistry and emerge into laboratory analysis as a recoverable record. The calibrated date range established by radiocarbon analysis of the textile fiber traces, approximately 220 to 310 AD at 95% confidence, broadly consistent with the coin evidence, places the deposit within the window that the political history makes meaningful. The physical evidence and the historical context arrive at the same horizon from different directions, and at that horizon they find each other. The Roman road of the Frome area, still traceable in parts of the Somerset landscape, as a slightly raised line across the field pattern, to subtle earthwork that aerial photography and ground survey have confirmed along portions of its route, represents the most durable physical survival of the infrastructure that connected the burial site to the wider world of its period. The road itself is older than the Hoard, already established before the Corrosian period and still in use after it. Its straightness, a record of the Roman engineering principle that the most efficient path between 2 points of commercial or military significance is the one that accommodates the landscape's obstacles as minimally as possible. The people who used it moved through the Frome Valley at the pace of their traffic, foot, horse, cart, and past the floodplain margins where the river moved beside the road through its seasonal cycle of flooding and recession. A late spring morning in that landscape, viewed from the paleo-environmental record and the coin sequence and the organic traces in the burial soil, has a specific quality that is accessible even at a distance of 17 centuries. The air would have carried the smell of the valley's vegetation after the winter flooding receded, the particular organic richness of alluvial soil returning to productivity. The Mendip Hills would have been visible to the south as they are today. The same ridge, the same skyline, the same relationship between the high ground of the hills and the low ground of the floodplain. The road would have been in use, its traffic audible perhaps at a distance, the sound of ordinary commerce moving through the ordinary morning. The river would have been at a moderate level in the spring recession, still carrying the volume of the winter rains, but already lower than its peak, the banks beginning to firm as the ground drained. Someone walked to the edge of that ground with a ceramic pot containing 766 coins wrapped in linen, found a spot at the margin where the cultivated field met the floodplain zone and dug a hole 30 centimeters deep. The physical effort of it is recoverable. The weight of the pot, with its coins pressing against the wrapping, the silty clay of the floodplain yielding to whatever tool was used to open the ground, the placement of the vessel in the trench, and the covering of the hole with the displaced soil tamped back down to something approaching the surface's original level. The whole process, in terms of its physical labor, would have taken a short time. The decision it represented had likely taken much longer. What could not be anticipated, what no one burying savings against an uncertain future can anticipate, was the particular form that the uncertainty would take, not the return of better circumstances, not the political stabilization that might have made retrieval safe and straightforward, but the permanent non-return of whoever made that decision on that morning. The ground closed over the pot, and the mourning continued around the point of its burial, the grass growing back over the disturbed soil, the seasonal flooding of subsequent winters, gradually building the thin layer of additional deposit that would eventually place the hoard below the plow zone. The river continued its lateral movement across the floodplain, the slow migration of its channel that paleoenvironmental analysis documents as a persistent process across the centuries. The world reorganized itself above the sealed ceramic container in which 17 centuries of accumulation were already in progress. The pollen traces in the burial soil, grass and flowering plants from a specific late Roman summer morning, preserved in the sealed darkness of the ceramic vessel through the full duration of the political and cultural changes that followed, do not record any of this subsequent history. They record only their own moment, the biological output of a warm season in a Somerset valley, captured in the soil that surrounded a ceramic pot at the instant it was placed in the ground, held there in the absence of light and oxygen and disturbance, quiet inside the sealed space of the vessel's interior for all the centuries between their deposit and their laboratory identification. They are the most specific surviving record of the mourning in question. They do not explain the mourning. They simply hold it, the way ground holds everything placed in it long enough, in the particular darkness of a closed and buried space, unchanged by the world that continued above them. The western bank of the River Frome in Somerset holds a particular kind of stillness in the late afternoon. The silty clay sits dark and close-grained at the water's edge, overhung with grass that bends toward the current without quite touching it. The floodplain extends away from the bank in flat agricultural fields that carry, in certain lights, in certain seasons, the faint impression of having been shaped over a very long period of time, not by any single act, but by the slow accumulation of water moving, soil settling, and ground rising and falling in the rhythms of centuries. The sky above the Mendip Hills is wide and pale on these afternoons, the horizon low and unhurried, the whole landscape carrying its history in the quality of its silence rather than in anything visible or announced. The paleoenvironmental reports that have been filed since the 2010 excavation describe this bank with considerable precision. The silty clay of the natural floodplain. Context 005 in the excavation record is documented as a wet, seasonally inundated deposit consistent with the marshy margin conditions that characterized this reach of the Frome Valley throughout the late Roman period. The gravel substrate beneath the burial horizon still contains molluscan assemblages, the shell material of water snails and freshwater bivalves that lived and died in the shallow standing water of a Roman-era marsh, their calcified remains preserved in the undisturbed ground as a record of a floodplain environment that has largely drained away over the intervening centuries. Drainage, land improvement, and centuries of agricultural management have transformed the wet margins of the Frome into productive fields. The river still runs, the ground still holds what was placed into it. The Frome has been running for longer than any record documents. Its name reaches back to a Brittonic Celtic root. The word that early medieval sources preserve in forms that carry the meaning of something fine or brisk, a quality of water in motion, and the river's presence in the cultural landscape of this part of Somerset predates the Roman occupation by an interval that archaeology can frame, but not fully populate. The tribal territories through which the Frome passes, the lands the Romans entered when they moved through this part of Britain in the 1st century AD, were the territories of the Duratriges and the Belgae, communities whose names survive in the Roman record, but whose relationship to this particular watercourse was older than any Latin inscription. The Frome flows approximately 43 kilometers from its rise on the eastern slopes of the Mendips to its junction with the River Avon near Freshford, tracing a course that has shifted over geological and human time through the process of lateral meander migration, the slow sideways movement of a river as it erodes its outer banks and builds new material on its inner curves. That migration continues. The bank that the excavation team documented in 2010 is not quite the bank that existed in the Roman period. The bank of the Roman period was not quite the bank that existed before that. The river continues to rewrite its relationship to the ground it moves through, depositing and removing material in quantities too small to notice in any single season, but measurable across decades. What this means for the ground between the river and the find spot is simply that the landscape continues to change at the scale at which landscapes change, not dramatically, not with urgency, but persistently and without pause. The silty clay bank continues to receive the river's small additions. The fields continue to accumulate the effects of cultivation and drainage. The gravel below the burial horizon continues to hold the molluscan record of a marshier world, sealed there by the centuries of deposit above it. The hoard itself is no longer in the ground, it is in a museum in Taunton, but the relationship between the ground and what was found within it persists in the documentation, in the site drawings, the context records, the vial samples, the reports filed by the paleoenvironmental consultants, and that documentation continues to be read and cited and consulted by researchers who access it from many different places. The legal journey of the Frome Hoard, from the ground to permanent public ownership, followed the framework established by the Treasure Act of 1996. Under that framework, a find meeting the definition of treasure becomes property of the Crown at the moment of discovery, regardless of who discovers it and on whose land the discovery is made. The finder and the landowner are entitled to a reward assessed by the Treasure Valuation Committee, an independent body whose determinations reflect the market value of the objects as established by expert consultation. The process is formal, documented at each stage, and designed to ensure that significant finds reach public institutions rather than private sale. In the case of the Frome Hoard, the treasure inquest was convened in the usual manner. The coins and associated finds were formally declared treasure, and the valuation process proceeded through the committee's standard assessment. The reward determined for the Frome Hoard was £320,250. That figure was shared equally between Dave Crisp, the detectorist who made the find, and the landowner on whose agricultural field the deposit was discovered. The payment represents the legal recognition of the find's assessed value, and it is recorded in the Somerset coroner's case file alongside the documentation of the inquest itself. Those records, the formal legal instruments through which a deposit placed in the ground in the approximate period 290 to 305 AD, passed into the possession of the crown and subsequently into public institutional ownership, are held in institutional storage as a paper record of a transaction that is simultaneously mundane and genuinely unusual. The administrative forms that document the transfer of a late Roman coin hoard are the same forms used for any treasure find. They are filed, retained, and available to researchers who need them. The acquisition of the hoard by the Museum of Somerset in Taunton was funded through a combination of the treasure reward payment, which the museum applied to secure the collection from the Crown, and supplementary grants from the Art Fund and the Heritage Lottery Fund. Those grants reflect the institutional judgment that the Frome hoard represented a find of sufficient significance and public value to warrant support from funds specifically established for the preservation of cultural heritage. The museum's Roman gallery, reopened in 2011 following a period of refurbishment, was the destination for the collection. A purpose-built display case was constructed for the hoard, glass-fronted, environmentally controlled, internally lit, and within it the 766 coins were arranged in the sequence of their catalog, the reconstructed ceramic vessel placed at the case's center. The display has been accessible to the public since the museum's reopening in a permanent gallery that also holds other material from the Roman occupation of Somerset, including finds from the Mendip lead mining district and material from the Roman town at Ilchester. To stand in front of that display case is to be in the presence of something that spent 17 centuries in the ground under a field near a river, and that now spends its time in a controlled environment inside a stone building in a market town. The coins do not look like the kind of objects that have been through what they have been through. They are arranged in rows, each one photographed and catalogued, each one occupying a fixed position in a sequence that the conservators and numismatists at the British Museum established during the weeks of mechanical separation that followed the hoard's arrival in London. The ceramic vessel's reconstruction, the sherds rejoined with fine adhesive, the vessel's form restored to something close to its original shape, sits at the center of the arrangement and makes the container visible as an object in its own right, separate from the coins it once held. The case is quiet. The gallery around it carries the low ambient sound of a working museum, footsteps on stone floors, the occasional voice at a distance, the controlled air of a building that manages its own climate. The coins are simply there, held in the conditions the institution has established for them, in the county where the river still moves. The full catalog of the hoard is held in a form that allows access without physical presence. The Portable Antiquities Scheme maintains an online database at finds.org, UK, and within that database, every coin in the Frome hoard has its own record. Each record includes photographs taken under conservation lighting, measurements of diameter and weight, compositional data from X-ray fluorescent analysis, a typological identification, and a cross-reference to the published scholarly catalog of the hoard. The records are publicly accessible from any connected device. A researcher in one country can examine the photographic record of a specific Corrosian coin from the Frome hoard, turning it in the digital record to see both obverse and reverse without entering the Museum of Somerset, without traveling to Somerset, without any physical proximity to the object at all. The database entry for any individual coin from the hoard is a small, specific, very complete document. The coin's physical dimensions, its metal composition, the name of the ruler whose image it bears, and its relationship to every other coin in the assemblage, all available in the form that digital institutional records take when they are well maintained and properly indexed. This is one of the quieter forms of persistence, the persistence of the well-organized record. The hoard exists in the museum in Taunton, and it also exists in the database, and the relationship between those two forms of existence is that the database makes the museum's collection accessible to people who cannot visit it. The coins themselves cannot be multiplied. There are 766 of them, and there will always be 766 of them, each one occupying a fixed position in the catalog, and a fixed position in the display case, and a fixed position in the geological and cultural history of the Froome Valley. But the record of them can be read anywhere, at any hour, by anyone who knows where to find it. The river continues its own form of record keeping, which is less organized and considerably slower. Lateral meander migration, the mechanism by which a river shifts its channel over time, is a process that operates at the scale of meters per century in a low-gradient floodplain environment, like the Froome Valley. The outer bank of a meander erodes as the current pushes against it. The inner bank accumulates new material as the current slows and deposits the sediment it carries. Over decades, the channel shifts. Over centuries, the shift becomes significant. The current position of the Froome's bank, near the find spot, is not the position of the Roman period bank. The difference is not dramatic. It is the difference that accumulates when a river moves at the pace that rivers move, continuously and without urgency, over a period of 17 or more centuries. The silty clay that is being deposited on the inner bank of the current channel today will, over a long enough interval, become a layer in the stratigraphy of the floodplain, indistinguishable to a future excavator from the layers that were deposited in the same way in every preceding century. The river makes its record in the ground. The ground holds it for a while, and then the river moves again. The floodplain has been managed and modified in ways that slow this process without stopping it. Agricultural drainage has lowered the water table across much of the Somerset levels and the river valleys that feed into them, reducing the extent of seasonal inundation that characterized the Roman period floodplain. Land improvement over the medieval and post-medieval periods progressively converted wet pasture and marsh into the flat arable fields that now extend to the Froome's banks. Those modifications have left their own traces in the ground: drainage channels, field boundaries, the patterns of plowing recorded in the disturbed stratigraphy of the upper soil layers. Below those traces, the Roman period floodplain deposit persists in the undisturbed horizons, carrying its own record in the molluscan material and the pollen assemblages and the chemical signatures of the sediment itself. The find spot of the Froome Hoard is known. Its location is documented in the excavation record and in the Portable Antiquities Scheme's spatial data. The field from which the coins were recovered is a working agricultural field that has continued to be cultivated in the years since the excavation. The trench that the archaeologists dug in 2010, the careful photographed soil-sampled excavation that removed the deposit and documented its context, has been backfilled and returned to cultivation. The surface of the field shows nothing of what was beneath it. The plow continues to turn the soil above context 003, the mid-brown silty clay burial horizon, and the gravel substrate below it continues to hold the molluscan assemblages of the Roman period marsh, undisturbed by anything that has happened above it since the pot was placed there and the ground closed over it. To think about the field in this way, as a surface that holds its history in the layers beneath it, each layer a record of a different period, each period's record preserved in the conditions that the layer above it created, is to engage with the same logic that the excavation team applied when they recorded context 001 as the mechanically disturbed plow zone, context 002 as the upper undisturbed subsoil, context 003 as the burial horizon, context 004 as the lower subsoil and context 005 as the natural gravel substrate. Each context number is a notation in the language of stratigraphy, and together they constitute a vertical record of the field's history, readable from the bottom up as a sequence of depositional events. The Hoard occupied context 003. The pot rested on context 004. The gravel of context 005 lay beneath it all, unchanged since before the deposit was made, recording in its molluscan content the wet floodplain margin that the Hoard's maker would have known as the ordinary condition of the ground near the river. The Museum of Somerset holds not only the coins and the reconstructed vessel, but also the study collection materials that accompanied the main display objects from the excavation and conservation process. Among those materials is the sealed glass vial containing the degraded organic matter recovered from inside the ceramic pot, the material that laboratory analysis identified as consistent with plant fiber, most likely linen or hemp textile. The vial is small. The material inside it is dark and fibrous, compressed into the pinch-sized sample that the soil scientists extracted from the internal matrix during analysis. It is labeled with a context number corresponding to its position within the burial, the context number that places it precisely inside the ceramic vessel, in the space where the textile wrapping once lay in contact with every coin in the assemblage. The vial is stored in an archival drawer in the museum's study collection, in the conditions that archival storage provides: stable temperature, controlled humidity, the darkness of a closed drawer in a climate-managed building. The textile itself no longer exists as textile. The plant fibers have degraded over 17 centuries of burial into the chemical traces and fragmentary physical forms that laboratory analysis is able to identify and document, but not restore. What can be known about the wrapping is that it was made from a plant fiber, linen or hemp, the two most common materials used for textile manufacture in late Roman Britain, and that it was present in sufficient quantity to leave identifiable traces in the soil that surrounded and permeated it during the centuries of burial. What cannot be known is how it was made, how it was folded, how tightly it enclosed the coins, or anything about the hands that folded it. Your textile is a presence in the record, documented by the laboratory report that identifies its degraded traces and cross-referenced in the published catalog to the context number that places it inside the vessel. It is also, in the plain sense, gone, present only in the form of what it became after 17 centuries in the sealed environment of a ceramic pot in a silty clay burial horizon in a floodplain field in Somerset. The radiocarbon date, determined from those fibrous traces, a calibrated range of approximately 220 to 310 AD at 95% confidence, represents the laboratory's best characterization of when the plant from which the textile was made was growing. That date is consistent with the numismatic evidence for the Hoard's burial. The latest coins in the assemblage date to no later than 293 AD, and the period of most plausible concealment, given the political and economic conditions recorded in the broader archaeological and historical evidence, extends from the late 280 SS into the first decade of the 4th century. The textile fiber and the coins and the ceramic vessel and the stratigraphic context all point to the same approximate window. Each line of evidence was developed independently and arrived at the same approximate place, and the convergence of those independent lines of evidence is what gives the dating its measured confidence. Or that measured confidence is the quality of the record at its most useful, not certainty, which the evidence cannot provide, but a well-supported probability range that multiple forms of analysis have each independently arrived at, and that none of them have contradicted. The coins establish a terminus post quem. The radiocarbon date provides a calibrated range. The stratigraphic context confirms that the burial horizon was not disturbed after the Roman period. The paleo-environmental evidence characterizes the environmental conditions at the time of burial. Cornelius' data records the metal composition of the coins in a way that is consistent with the documented history of late Roman monetary practice. Each of these forms of evidence was generated by a different analytical method, recorded in a different kind of report, and archived in a different institutional location. Together, they constitute a record of the hoard that is denser and more complete than the record of almost any other object in the Museum of Somerset's collection. The hoard's reach into the research community extends beyond the museum's display and the Portable Antiquities Scheme database. The scholarly publication of the Frome Hoard, the catalogue and analytical reports produced by the British Museum's numismatic and conservation specialists in the years following the excavation, is held in university libraries and research institutions, who are cited in subsequent studies of late Roman coinage, referenced in discussions of Corrosian numismatic policy, and of coin hoarding patterns in the period of the crisis of the 3rd century. The single coin in the assemblage bearing the legend IOV, the Corrosian piece interpreted as a direct appeal to Jupiter, and attempting to frame a breakaway emperor's authority within the established religious vocabulary of Roman imperial legitimacy, has been cited in numismatic and historical literature on Carausius's propagandistic strategies, because it represents one of the more explicit surviving examples of that strategy expressed in coin legend. The coin is in the display case in Taunton. Its image is in the Portable Antiquities Scheme database. Its analytical data is in the published catalog. Its significance for the study of Corrosian coinage is in the footnotes of subsequent scholarly work. A single coin moves through several registers simultaneously, occupying the museum case and the database record, and the scholarly literature at the same time, each register holding a different aspect of what the object is and means. The institutional framework that made all of this possible, the Treasure Act of 1996, the Fines Liaison Officer Network of the Portable Antiquities Scheme, the British Museum's Conservation Laboratory, the Treasure Valuation Committee, the grant-making bodies that funded the acquisition, is itself a kind of preservation apparatus, one that operates not on the objects directly, but on the conditions under which objects found in the ground reach permanent public ownership and remain accessible to study. The Fines Liaison Officer to whom Dave Crisp reported his discovery in April 2010 was a node in that apparatus, a person whose function was precisely to receive the calls that detectorists and walkers and farmers make when they find something they cannot quite account for in a field or on a riverbank. The call was made. The liaison officer received it. The apparatus engaged. The record of a deposit made in the ground approximately 17 centuries earlier began, from that moment, to be built in the form that an institution creates and maintains. The river does not know about the apparatus. The river continues its lateral migration, its seasonal fluctuation between low summer flow and higher winter levels, its slow redistribution of the silty clay material it carries from one part of its course to another. The floodplain continues to receive what the river brings to it, and the ground continues to hold what was placed within it at every depth the plow does not reach. The field above the fine spot continues to be cultivated in the ordinary patterns of an agricultural field in Somerset, producing its annual crop in the cycles that have characterized agricultural land use in this part of England across the centuries that the Roman coins were accumulating in the ground beneath it. The season turns, the crop is planted, and harvested. The field turns brown and gray through the winter months and returns in the spring to its familiar agricultural greens and yellows. The study collection drawer in the Museum of Somerset is closed. The vial of degraded textile fiber is inside it, labeled and cataloged, and held in the stable conditions of a climate-controlled archive. The material in the vial is approximately 17 centuries old, by the most conservative reckoning, and somewhat older if the plant from which it was made was grown in the earlier part of the Hoard's accumulation period, when the oldest coins in the assemblage were new. The vial itself is a few decades old. The archival drawer is somewhat older. The building that holds the drawer has stood in Taunton for considerably longer than any of the material it currently contains. Outside the building, the town of Taunton continues in its ordinary operations. The market, the traffic, the schools and offices, and the slow seasonal change of its streets, entirely indifferent to the fact that a sealed glass vial in one of its buildings holds the degraded remnant of a piece of textile that was pressed against a Roman coin sometime in the approximate period 290 to 305 AD, when the man who became the last emperor of a breakaway Roman Britain had already been killed by his finance minister, and someone in the Frome Valley was making a decision about what to do with the savings they had accumulated across 50 years of a complicated world. The degraded fiber in the vial was once a plant growing in that world. It was harvested and spun and woven into a textile in that world. It was folded around coins that had passed through the hands of people living in that world. It was placed in a ceramic vessel and pressed into the dark, and the dark received it and held it, and the centuries accumulated above it in the way that centuries accumulate in ground that is left undisturbed below the reach of the plow. When the conservators at the British Museum extracted the soil sample from the interior of the vessel and sent it to the laboratory for analysis, the fiber was identified in the analytical results by the chemical and physical signatures it retained from the material it had once been. The laboratory produced a report. The report was cited in the published catalog. The catalog is in libraries. The fiber is in the museum's study collection. The river continues to move. That is the whole arc of the thing, and it does not require anything more dramatic than what it is. A deposit was made. The ground received it. The centuries passed in the way that centuries pass, in undisturbed ground, slowly, without record, with the molluscan assemblages and the pollen traces accumulating in the matrix as the only witnesses to the conditions of the world above. A signal registered on a metal detector on an April morning. A phone call was made. A careful excavation was conducted. A conservation process separated and documented every element of the deposit. An institutional process moved the objects into public ownership. A museum built a case and placed the objects in it. A database record was created. A laboratory vial was filled and labeled and filed in a drawer. And the river continued its lateral migration, and the field continued to be cultivated, and the ground below the disturbed zone continued to hold the record of a Roman period floodplain in the molluscan material of its undisturbed substrate. The vial sits in its drawer in the dark of the archive. The coins sit in their case in the lit gallery of the museum. The database record is accessible to anyone with a connection and the knowledge of where to look. The field is quiet. The river moves at the pace of rivers moving. The Mendip Hills hold their position on the horizon above the Frome Valley. The same hills whose lead mines once sent their product down the road that passed through this part of Somerset toward the coast and the wider empire. That road is mostly gone now, recoverable as a faint earthwork in certain fields and a documented line on the archaeological map of Somerset. The empire that built it is gone in the way that empires go, not all at once, but gradually, its structures absorbed and replaced and overlaid by what came after, until what remains is the road's ghost in the ground, and the coins in the glass case, and the fiber in the labeled vial, and the river still moving in the flat land below the hills. The drawer is closed. The building in Taunton holds its archive in the dark and the stillness of a controlled environment, the temperature steady, the humidity managed, the material inside the vial persisting in the conditions the institution has established for its persistence. Outside, the county of Somerset continues under its wide sky, the fields holding their ordinary shapes, the river running in its channel, the banks soft and silty and overhung with grass, slowly continuing the erosion and deposition that has been reshaping this part of the floodplain for longer than the ceramic vessel sat in the ground. The Hoard waited 17 centuries in the dark before anyone came for it,